Cool. All right, so today we're going to talk about pass by reference and pass by value. Um, so right before this, when I was talking with Sean, I was telling Sean, like, Sean, I know how this stuff works, but like the more I look at it, the more confused even I get. This is actually it's one of those things where you can learn it, and you can get a pretty good. I would say that this is almost something you get like a pretty good feel for at the end of the day. Like it's something that yes, you can learn academically, you can kind of know and memorize, but as you write more and more programs, like this will become kind of more second nature to you. Like you'll get a good intuition for how this works. What I mean by pass by reference and pass by value. So this is an example of something very simple we could do, right? I'm creating a new variable called ARR, right? And I'm pointing it to an, I'll turn off lights really quick so you can see it. Cool. And I'll turn the lights back on when I go back to the whiteboard. For now, just focus on the slide here. So I have an array with there's three numbers, 1, 2, 3. I call it ARR, right? I create another variable called new ARR, and I set it equal to ARR. Cool. We do this all the time, right? We create one variable, then we create a reference to it in another variable. Then in this new ARR, we're saying push, right? Basically, let's add a number to the end of this array here, right? And when we console log it, we get new array is equal to 1, 2, 3, 4, and ARR is equal to 1, 2, 3, 4. This is something that looks simple, but I'm just going to diagram. I'm actually going to go to the next slide really quick, and I'll contrast it with what's going on behind the scenes, and we can talk about why this is actually, there's a lot more going on behind the scenes here than what it first appears. But this makes sense, kind of, right? We have a variable, we have another variable, we set it equal to it, and then the second variable, we're pushing in a 4. But I guess we take a stab at this right now. Can anybody tell me why? So new ARR as 1, 2, 3, 4 makes sense, right? We have 1, 2, 3, and we're adding a 4 to it. Why does this ARR? Why does this initial variable change as well? Anyone?
Because they're linked. I mean, because ARR is equal to new RR.
Right. So yeah. So I guess another way to phrase it is that we have this array here, right? ARR is pointing to this array, and then new ARR, it sounds like we were saying, is also pointing to the same array. That's how they're linked, right? So whenever this changes, this other variable also changes. Cool. And once again, we're gonna come back to this. This is like something that's like, it gets progressively more and more kind of, brain bendy as you go through it more and more. Okay, 2 more examples here. We have ARR equals 1, 2, 3. We have new AR equals 1, 2, 3. Okay, I'm not setting this equal to AR. I'm setting it equal to another array with the same values, right? New array, I'm pushing 4. I console log out. The new array is now 1, 2, 3, 4, and the original array is just 1, 2, 3, right? So according to what you just said, in this case, these two aren't linked at all, right? Like they're both equal to something that just happens to be the same. But because they're not linked, changing one has no impact on the other, even though these values are the same, right? Okay. Here's something very interesting as well. Once again, we start with ARR equals 1, 2, 3. We have new AR equals array.slice. Are you guys familiar with what .slice does?
It returns like a substring. No, like you cut out a certain part of the array.
Right, yeah. Array.slice can be used to create like a substring or a subarray if you want. Do you know what happens if we pass it in with no arguments? We just call it. Sorry.
Returns the same thing.
Right. It returns this. It returns the same thing. Now, what does same thing mean here? The original array. Okay, great. So if it's returning the original array, right? This is going to give me basically ARR again, right? Because I'm taking ARR, I'm just taking the original array of ARR and passing it back to you, right? Now I do new array.push 4. I mean, they give the answer away here, obviously, so I can't really kind of, make it a surprise or anything. But now when I look at new array, it's 1, 2, 3, 4, right? Because I had the original array, I push a 4 to it. But why does the original array not change? Why is this still only 1, 2, 3? Right? Juxtapose this case here, right? This case I think is pretty intuitive, right? Like these two have no connections. There's two random variables that happen to equal the same thing. We log them. Whatever you do, one is kind of lives its own shell, right? Like that. Like I think this one's pretty clear. But in this case, why does this do this, right? Why does the old array stay the same? Whereas in the first slide that we looked at here, once again, we're setting equal to, right? In this case, why does this happen to both of them at the same time? Any guesses why? There's no method getting called on it. Okay, interesting. Why would the method be important here?
Like it copies whatever value.
Yep. So okay. So here, let's turn the lights back on and I'll move over to the whiteboard here, right? Because I think this is like pretty interesting to diagram out, right? So if we go back to the first example that we looked at here, this one here, right? I have this little box. 1, 2, 3. This is the actual like thing in memory, basically, right? My computer actually stores this value here, right? And what I'm doing is I'm creating this variable called ARR, okay? And I'm basically what I'm doing is I'm creating I don't want to get too technical here, but this is basically just points to this, right? And so whenever I'm looking at ARR, it basically points to say, oh, what you really want is this value, right? Cool? This makes sense, right? Now, in this first example here, what I also did was I also created this other variable called new ARR. Where is this new ARR pointing to? It's pointing to nothing. If it's not pointing to anything, then how can I do a dot push on it? Sorry, yeah, sorry. In context of the example on the first slide, where does new ARR point to? ARR. Does everyone agree, or does someone think differently? Okay, cool. So this is interesting. So now what you're saying is, okay, when I do new AR dot push, this points to this, which points to this. So I add a 4 here, and that's why when I look at this, it's 1, 2, 3, 4, and when I look at this, it's also 1, 2, 3, 4. Is that kind of where we're going with this? Okay, so in that case, then let's go to like a REPL really quick, right? Ignore all of this. So we have our ARR equals, can everyone kind of see on my board on the screen? I'll zoom in as big as I can. Can everyone see? Cool. All right, so in this case, ARR is just 1, 2, 3, right? I copy this and I say, okay, new ARR is now equal to R. Okay. And example here, we did a new ARR dot push, and we did a 4, right? And then we did a few console logs here to see kind of what we get, right? In the first case, we're console logging out new ARR, and in the second case, we're just console logging out ARR. Here, right? We run this and we get exactly what we see on the slide, right? Both things equal 1, 2, 3, 4. Okay. Now, interesting enough, in this case, then, oh sorry. So then, interesting enough, when I go back to this second slide here, what exactly is going on here? Actually, you know what? Sorry, didn't mean to cut you off there. Even before we do that, right? Let's just go back here, right? And let me ask you this. And so let's just say, so new ARR is pointing to ARR according to what you guys just told me, right? So then I say, okay, I'm going to point ARR to somewhere else now. I'm going to say it's going to equal to something called 4, 5, 6, right? Perfectly valid. I changed the reference of 1 to another now. I changed the ARR from pointing from 1 right here, right? And now I have another thing on my computer's my computer memory here, another memory block. And I'm saying, okay, you no longer point there. You point here. Cool. Now, when I console log ARR, what should I get? Based on the code I have up on the board. Does everyone agree? 4, 5, 6? Yeah. Cool. And what should I get if I console log out a new ARR? So, okay. This is going to be really easy. There's only 4 of you, so I know exactly who has and has not answered. So what does everyone think that this is going to become? What do you think new ARR is going to console log out to? 4, 5, 6?
4, 5, 6.
Okay, there's only two possible answers here, so you guys have a 50-50 shot of getting either right? So let's console log this out. Okay. ARR, you're right, you're all right. It's 4, 5, 6. Mu ARR, however, is 1, 2, 3, 4 still. Right? So what does that tell us at this point? Right, and UR is looking at the original array, and I guess this is going to be hard for the folks who are watching this later on at home, but essentially on the whiteboard, right, it means that somewhere in our diagram, our arrows are pointed incorrectly, right? Like, there's no way these arrows are correct, and we're still printing out 1, 2, 3, 4, right? Something must be telling us, okay, mu AR is now pointing to this, and ARR is now pointing to this, okay? I'll explain what's going on, but can you guys at least like nod that you're understanding like what we're observing are the results of what's happening right now? Okay. Cool. So then if I go back to the second case here. Okay, cool. So in the second case here, right, with the slice here, we have our ARR, right? Initially it's pointing to this 1, 2, 3 here. Okay, so initially we have our ARR, right? Point to 1, 2, 3, based on what we're seeing here. Okay? Mu AR equals mu AR dot slice, right? Someone said it returns the original, right? So where do you think the arrow, where do you think that points to? Where does that point mu ARR to?
1, 2, 3.
Okay, so your options here are really just ARR or just array. You say array. There's only 4 of you. I know exactly who has and has not answered yet.
Let's do R.
You think it points to ARR. You say it points to 1, 2, 3. 1, 2, 3. 1, 2, 3 or ARR? 1, 2, 3. Okay. So now you're saying this now points to 1, 2, 3. If that points 1, 2, 3, right? So then if I say, okay, mu ARR dot push, right? Same code, I haven't changed the slides since we last looked at it, right? Mu ARR now pushes 4 to it, right? We're saying, okay, this points to 1, 2, 3. I add a 4 here. Cool, right? When I console log out mu ARR, I get 1, 2, 3, 4. Perfect normal. I console log out ARR, I get 1, 2, 3. Where did that come from? Generally, where did that come from, or what happened there? I'm sorry? We did push in a value, right? But what you're saying is, look, if this is pointing to this, and this is pointing to this, and we change this, then theoretically, like, this is going to change, right? And this is going to change. However, what we're really seeing in practice is that only one of these is changing. I know this is confusing, and I'll walk back to exactly why this is, but I just want you guys to understand, like, why this is like an important concept in the wild when you do program. Like if you ever do come across an instance where you're like, this should equal this because it's set equal to this, but it doesn't. What's going on here? More likely than not is that you probably have a pass by reference versus a pass by value error or misunderstanding of some sort of your code, okay? So this is very common, right? Is that when you set one variable equal to another, you do something to one of the variables, but it doesn't, like the changes don't carry over to the other one, or it does in a way that you didn't expect it to. That's like that's probably the most common kind of like visualization of what happens when one of these kind of issues happen. Okay, so let's go back to the beginning here. I'll leave this up here, right? Okay, cool. Okay. Pass by reference versus pass by value. I think the best way that I can think of explaining this in some way is that everything passes by value in JavaScript with the exception of objects. Okay? Do you remember how, during our class last week, we had this kind of, not debate, but, we were like, oh, there's 2 ways to check to see if something is an array or not, right? We're going to do array.isArray or type of equals, not array, but object, right? So array is actually an object too. So for now, let's just assume array is also an object. This is an object. Okay. Everything in JavaScript passes by value except for objects. Yes.
So I try to like define array as a variable, like as a number.
Yeah.
It doesn't change over.
You try to define an array as a number.
Just whatever variable as a number.
How would you define that?
Just variable like number equals to 5.
So you're trying to say if you write some, or I'll just do it here. So tell me what to type here, and we'll let the JavaScript compiler tell us exactly what's going on here. So you're saying, let's just do down here. Okay. So you're saying var.
Yeah, it's like just a equals to 3.
A equals to 3.
And then you var b equals to a.
Oh, sorry, I don't have there. Okay, it really likes autocomplete. Var b is equal to a.
Then you have like b equals to 5.
B is equal to 5.
Yeah, and like in your reasoning, it's like it should like change the value of a. If you console log a,
Cool, that's a good. Let's try it out. So we're console logging a, right? And we're console logging b. Okay, a is 3 and b is 5. Okay.
it's like doesn't really change the original.
Right, and I'll tell you why dot push, like when we did dot push on it, it did change it, right? But right here we're just setting what equals to, it doesn't. I will walk into it in more detail right now. This is why that is okay. But just know that everything in JavaScript passes by value except for objects. They're kind of like the outlier here, right? Okay. So originally when I created this, so back on the first slide here. Cool. Okay, cool. We're gonna go through line by line exactly what's happening here, okay? In line 1, we're saying variable equals 1, 2, 3. So that's where I draw this arrow here, okay? Line 2, I have a new variable that says new array equals ARR. What is ARR right now? Is it an object or a non-object?
It's an object.
It's an object, right? Because it's basically pointing to an array. It's an object. So everything else would pass by value, but it's an object, right? So we're doing pass by reference. What does pass by reference mean is ARR is going to say, okay, great, let me, and this might not be exactly kind of how it works underneath the hood, but conceptually this is how it works. New ARR is, okay, great, I'm now equal to ARR, which is an object. Cool. So what does AR equal? Well, AR equals this array of 1, 2, 3. So I'm actually just going to say, okay, great. I'm actually not going to point my arrow directly to ARR. I'm going to point it to what the ARR is pointing to.
So why is that?
Because ARR, so let's just do another example down here, right? So let's say we have something called, we have foo and bar, okay? So let's say bar is equal to 2. Okay, and then we have foo, right? Or even we just console log here with the example there, right? We're saying foo is now equal to bar. Well, bar is basically not an object. So basically, if bar equals 2 and we point is equal to 2, this is now going to equal to another 2.
Why can't we use equal to bar since it's already equal to 2? Because it is abstract.
Okay. Do you mind if I cover this array first, and then we'll come back to what happens in other cases? Because like I said, like objects are kind of what like the outlier is. So we can. So then when I talk about this, it might get a little more confusing. So if I cover the array part first, hopefully it'll make the rest of it make a little bit more sense.
Because I thought it'd be a little easier since R already is already pointing to the object. I can't use it.
Right. Exactly. So, but the question then, or like what we saw that really made things more difficult, right, was if I'm pointing new ARR to just ARR, now what happens with ARR and ARR when ARR points to something else?
Then it should follow ARR.
So for now, let's just follow this example really quick and kind of okay. So now if this is what's happening here, right, is I'm saying, okay, I'm pointing to an object, but I'm actually pointing to what this object is pointing to, right? I'm pointing to ARR here. Notice how what's important here is that these two are pointing to the same exact thing, right? This is and this is not always the case, and this is going to be what's going to be tricky down the road. But right now, this is so I mentioned this doesn't exist just yet. Okay, these two are pointing to the same exact thing, right? So so on line 3 now, when I do new ARR dot push 4, what I'm doing is saying, okay, whatever I'm pointing to, right? I'm new ARR. Whatever I'm pointing to, let's add a 4 to the end of it. Add a 4 here now. Great. And so now when I console log out new ARR, it's going to be a 4. And when I console log out ARR, it's going to have 1, 2, 3, 4 as well. So we now at least know this paradigm makes sense relative to that, right? Right. Let's see if this paradigm also makes sense to what else happens. Like I said, the one on the left, I'm just going to ignore for now because this is, it's like kind of like, I don't think it's really like that confusing to realize you have two things that happen, like two people named Mike, they both happen to be named Mike, but they're fundamentally different things, right? Like it doesn't really matter what you do one to the other, right? Well, let's take a look what's happening on the right here. Now we're saying ARR is equal to 1, 2, 3, right? And new ARR is equal to ARR.slice. This is what happens when we don't pass by reference, when we pass by value. Okay, very important here. When we pass, so what I just described in the first pass by reference, when you pass by value, like we're doing with AR.slice, right? What's actually happening here is we're actually creating a copy of this. We're creating another duplicate object, also called 1, 2, 3. Let us think here for a second, okay? And we're pointing this to this.
The new object.
Right. So this is, we'll say, obj1, and this is obj2. Okay? Now, if this is the case, does that example on the right make sense now, right? I'm saying new AR, okay, push me a 4. Okay, we're pointing to object 2. Sure, I'll add a 4 here. Log me out. I have 1, 2, 3, 4. Log out ARR. Completely own thing. I have 1, 2, 3. Okay? In fact, this is how it works for I think almost every non-object in JavaScript, right? So now going back to your question earlier, like, oh, like what happens if it's just 2, right? Is 2 an object? It's just a number, right? So when I say, okay, AR equals 2, new AR equals AR, what I'm really saying is now I'm doing pass by value, right? I can't do pass by reference because these aren't objects. These are just like primitive data types, right? This equals 2, right? What I'm really saying is, okay, let's have another one. 2, right? So AR is pointing to 2, new AR is pointing to 2, right? So I can do whatever I want to this. I can add a million to it, right? It's not going to impact this. And now you see why pass by reference versus pass by value is important, right? When you pass by value, you have your own version of this that you can do things with. When you pass by reference, what you're really doing is you're able to you're both sharing a link to the same thing, and then when you change that one thing, it changes this for everyone else who's also pointing to that pointing to that thing.
But so if you change the type of array, is that array?
Okay, so changing type of array, how would I do that? Okay. Right. Okay. So before I go into what happens when you change things later on, right? This model makes sense, right? Like these two things that I've laid out, right? Why in the first example, because it's an object, we're pointing to the same thing. So when I change one, it changes for everyone else who's also looking at that thing, right? In this case, I'm telling you is what happens when we do pass by value is we're basically creating another copy of the same value, and whatever I do to this, it doesn't impact the original. Does that make sense right now?
So pass by reference is just object?
Yes.
Oh, okay.
Yeah. I think type of equals object is probably the best test for that. I'll let you know if something else comes to mind that's not. But as far as I know, I think arrays and objects are the two main things that you'll see that's going to provide us.
So that's gonna like follow like a chain of stuff, right? You have
Right.
right.
That's going to follow the chain. I think what his question was, and this is a different color, right? is what happens, or how do I break that chain if I want to, right?
So I want to just like recapping. So pass by references means like technically one variable is linked to another variable which share a same object.
Which share like the same like endpoint, I guess you can call it.
Oh, same endpoint.
You can call it whatever you want. I'm just using terminology here. I think that makes sense to me, right? But it's like like we have two roads that lead to the same destination, right? Right? It's like you're meeting like someone named Mike for dinner, right? It's like you could both be going to dinner with Mike, but the question is it the same Mike or is it two different Mikes? That's going to change everything, right?
So pass by reference means it is the same thing.
Pass by reference means that you are looking at the same thing.
Oh, the same thing.
Okay. Pass by value means I'm just creating a duplicate value. You have your own thing you can play with. Okay. So I'll just put it up here really quickly. So when you pass is spelled P. Pass by reference. It's objects. Pass by value. I could say everything else, but I think it might be helpful for you guys to see like something like numbers, strings, booleans, I'm sure are too. But basically, like objects are kind of the things that you can change, right? And these are the things that when you pass something in, you're passing by a copy of it, not the value, not like the actual thing itself. Okay. Cool. Okay. So let's keep going to the next slide. I think some of these are going to kind of point to kind of maybe more fun things, right? And I haven't forgotten yet of like what happens when how to break these associations when you change one to the other. I think that comes up in 2 more slides. So I don't want to cover it right now and cover it again in like 5 minutes, but it is something that we're going to definitely talk about, right?
Sorry, is it the reason that it gets passed by value in the last slide with slice? Is that because like slice is an operation that like returns each value back to like,
Yep.
you're assigning?
Yep. So I think someone here mentioned earlier, like what does slice do? Someone said it returns the original, and someone else said like copy, right? So those two are very different things, right? One is to say, here's the object, take it, right? And that's like a pass by what? Pass by reference, right? Here's literally the same thing, take it, right? Well, what that slice does is basically it creates a copy of it. So then in essence, it does like almost like a pass by value. Like they're saying, hey, I made a copy of the same exact thing, take it, it's yours, right? You do whatever you want to it, I'm not gonna touch it. Or I have my own thing still, right? You take this and you modify, do whatever you want to it. I have my own copy. Okay, we're completely separate. There's no link between us, right? And so if we take this a little bit further, right? So normally when we think about like passing things, we're like, okay, equals, right? Like that's what we use, like A equals B equals C equals D, right? We do this over and over again, right? But when we pass a variable into a function, we're passing a variable, right? Like in essence, we're also passing things into, right? So in a function now, so once again, we have our ARR equals 1, 2, 3 at the very top, okay? We have this function, push 4. It basically, we pass in an array here, we're pushing 4 to it, and we're returning the array. And then I'm saying, this is what the function does, right? And here we actually call the function. We say new array equals push 4, and we're passing in 1, 2, 3. Once again, the answer is given to you, so I can't like talk about how this is going to come up. But we see that both new array and array is equals to 1, 2, 3, 4. Okay? Let's draw that out here line by line to see what's happening. Actually, I should erase those two. Okay, so line by line, okay? Line 1, 1, 2, 3. Cool. And I have this variable called array. Okay. I'm passing into it. So once again, I'm passing this array, which is a what? Right, it's an object, right? So what are we doing? Passing by reference. Great. Okay, so we're passing by reference, right? And when we pass by reference, what we're doing is we're saying, okay, we're pushing 4 onto it, okay? So this is a little bit janky, but so we go from line 26, we declare this thing here, We go down to line 31 because that's where we actually execute the function, right? And we create this variable called new array. Okay. What is new array equal to? We don't know yet, so I'm going to remove this arrow for now because we need to go through the function to see what new array is going to equal, right? We then move back up to line 28 now. We pass in this array, and we're saying array.push4, right? You said it's passed by reference, so we know that whatever we do to this array, we're doing it to this array, right? We're not making another copy of it and doing stuff to it and giving it back to you. We're doing it to this array directly. What are we doing to it in line 28? Pushing 4, right? We add a 4 to it. And then what do? We return the array. We don't return a copy of the array. We're not returning array.slice like we did in the previous slide, right? We're saying, here's the actual array that I'm using right now. Take it. Cool. So we return that array, and when we go to line 31, we finish the assignment. We say, okay, great. New array, you are equal to the array. So where does new array point to now?
Changed
Where? So let's say this is like 1, 2, and it points to another copy of down here, 3. Which one is it? 2. Right? And then we log out both. Yeah, so now when we log out line 33, we log out new array. Okay, great, new array. Where are you equal to? 1, 2, 3, 4. Array, where are you equal to? 1, 2, 3, 4. This is why this makes sense. Right? This is the only way in which this system has to be how we explain what we're seeing on the slides, right? If we're passing by a different copy of it, well, whatever we change to it, new array is going to be pointing to that instead, right? So in line 29, what if we did like an array.slice? What's going to happen then?
like return this array.slice.
Right. So let's say in line 29, yeah, line 29 becomes a return array.slice. We'll do an empty parentheses. So we're calling it, but we're not passing it any arguments. What's going to happen then?
Make a copy of the change.
Like the original is not changed.
Right, right. So exactly. So interesting enough, what's going to happen then is, notice how like this, I'm saying in line 29, right? And the location just matters a lot, right? Because we're passing in the original array, right? That thing right there. We're still pushing 4 onto it, right? None of this has changed. What I'm saying is I'm going to return array.slice. So what that's going to do is that's going to create another new array down here. And what's going to be in this array? Right, 1, 2, 3, 4. And then I'm going to point new array to that. So even in this case, so even if I did return array.slice, and I console log out both of them, they will look identical. And you'll be like, oh, what's happening, what's happening? But then if I do, new array.push5, that will only do it to this one, not the original. I'll just think of a second here. Like I said, this is one of those. Have you guys ever had like those like times when like you were saying a word over and over again so many times until it stops making sense to you? Like you realize how weird that word sounds. This is like one of those where like I feel like if you think about it for too long, your head just kind of explodes, right? But like I think intuitively, think about it, like kind of what's going on here. Hopefully, this is starting to make sense, and as you write more and more code, this will feel like more intuitive to you as kind of what's going on behind the scenes here. Okay. Does everything on this page, on this slide right now, make sense in terms of how this code is being executed, how the arrows are being drawn, and how we got to here? Everyone's good. Okay, it's only going to get harder, not easier. Cool. So here's another example, right? We're just going to skip the formalities and we're just going to call it an object in this case, right? So let's do this again here on this board. So we can cool. So once again, line 38, we have an object. I'll just call it OBJ here for now, for short. I'm setting it equal to an empty object. Okay. That's line 1, or line 38. Cool. Okay, line 43, what am I doing? Well, I'm creating a new object here. And then I'm passing in object, which is being passed by what?
Reference.
Say reference. Once again, it's only 6 of you here. I know exactly who's answering and who hasn't. It's not that hard to keep track. Okay, so once again, passing in by reference, right? I'm passing in this exact object, not a copy of it, I'm passing in this exact object to you. What are you going to do with it? Line 40, I'm saying, okay, let's add a, sorry, let's add a key to it called key, which is a bit confusing for naming purposes, but this is now key, right? And then what I equal? Val. Okay, that's in line 40. Okay, everyone so good? And then I return, do I return this one or do I return a copy of this one? Good, yeah, I return this one, right? And I return it and I set equal to new obj. So what does new obj point to? The same one. And so now in line 45 and 46, when I console log out obj and new obj, I'm printing out the exact same thing. Okay? And the reason why this can get confusing sometimes is that if you were to do like a pass by value, like in the slice example, like I mentioned, like if we add a slice to the end of it, your end result's gonna look the same, right? But if you try to do things with it, that's when you realize that they're actually different instances of the same object. In this case, we can test this out, right? If we add new obj, we add another key called foo equals bar, obj is also gonna get that same change, right? Because once again, we're pointing to the same exact thing. Okay? Good. Okay, cool. So we talked about objects, right? We talked about how pass by reference works with objects. I feel like we can probably kind of, step through an object assignment. Now the question becomes, I think was earlier asked was, great, what happens when we don't have an object, right? Let's say I have a number here. So I'll walk through this one really quick. And I think next slide is what happens when we do like reassignments of things. Cool. Okay. Okay. Well, my thing is 3, and I have this variable. I'll just call it num. Okay. That's what line 2 tells me. Okay. Pretty straightforward, right? Okay, I skipped to line 7, right? Because lines 3 through 6 are definitions, right? So we don't look at it, sequentially, right? It's an object method, so we go in line of what we can execute, right? Line 7 says, okay, great. Make me a variable called new num. I do, okay. And I'm passing a number, okay. When we pass in a number, what are we passing in, or what kind of pass by are we doing?
Value.
Okay, and so what does that mean exactly?
It's a copy.
Right. We create another copy variable called 3. Okay, and we say, here you go. Here's it. It's theoretically equal to what I am, but it's identical to me, but it's not me. Right? It's like I've cloned myself. Do what you want with the clone, not me. Okay. So we go back to line 3 now. We pass in a reference. Sorry, pass by a value. Right? The value of 3, and we say, okay, increment num by 1. So all that means is that this is the original, right? And this is a clone. Okay? We're gonna do clone plus plus, so we get 4. And now we're gonna say, okay, return back this 4. Okay? And when we return back the 4, where does new num point to now? The 3 or the 4? The original or the copy? 4. Okay? Pass by reference. We have one thing, we did things to it, everything links back to it, right? Pass by value means we have a duplicate value. We do things to one, it doesn't impact the other, right? So by the end of this now, this is a pretty clear example, right? We did something to num, but it was to the pass by value of num, right? Which is a copy of num, not num itself. Num is still going to be 3. New num is now going to be 4. Any questions? Because you're going to have to do this yourself in a little bit. And if you don't understand it now, it's going to be really, really frustrating when you start console logging things and they don't log out what you expect to log out.
If you didn't assign new number to the implication of that function, and you just like called the function with the original number variable in there, then it would change the original number, right?
Why?
Because you're not making a copy.
Well, so basically what we were saying is let's get rid of this part, right?
Yeah.
We just do add one number.
Yeah.
Right? Okay. So we pass the number through, right? So once again, number is not an object, right? So that's kind of like the foundation of all this, right? Number is not an object. So what are we feeding into add one? Are we feeding number into add one, or are we just feeding the value 3 into num1 into add one? The 3, right? So we pass in the 3, we add 1 to the 3, and we return the 4, right? At no point do we really do anything with number. So number is still going to be 3, and we can easily test this out, right?
Is that a global variable?
Number?
The var number?
In this case, yes.
Okay.
Yeah, in this case, yes. Var usually puts things on the, let's see, JavaScript is a function scope. So yeah, in this case, because this is like the outermost scope,
So
in the
it's global. Okay.
in this case, it's global, yes.
Okay.
But yeah, so let's let me just make sure, I forgot already, but I think it's like var num equals like, we'll say 3, right? God. Okay. No, like, I really appreciate like Repo trying to be helpful here.
Escape, that's the best way to get it.
Thank you. Okay, cool. I think it's also because I'm so zoomed in that it just does weird things to my like how I interact with it. Cool. Okay, and then we have a function. We call it add. Let's call it add. We're passing in. I'll even call it num here, right? And I'll do num plus plus return num, right? And so before, what we have been doing here, we do console.log num, and then we copy this, and then we call this was a new num. Right, and then here we have a new var new num equals to add num. I think this is what it was, right? Cool, 3, 4. Okay, so this is a direct copy of what we had on the slide. Haven't made any changes to it yet. And what you're saying is, let's just get rid of this, right? Okay. And then let's also get rid of this because this is not going to play. Okay. Yes.
The first variable is number.
The first.
The first line is number.
Oh, right. Yeah, sorry. Yeah, I can see if I can just, can I do a replace? No, I can't do a replace. Okay. Yeah. So basically all of this becomes, I can definitely do all this too. Yep, cool. Right. Cool, okay. Yeah. I almost used num there to show you it doesn't matter what you called it, but you're right, like in the slide it was called number, it's called num here. But like in this case, like it doesn't, and we could call it like the same thing. What's gonna happen is when we get into the function scope, we're gonna create our own version of num, and that's gonna supersede whatever this was out here, right? So I could have a variable called, you know, like foobar out here, right? And I could define my own foobar inside of here, and then whenever I'm inside of here, whatever I define foobar to be is gonna be like the official version, at least in my little function scope there. So I could call it num, but you're right, just to be clear, let's call it not num, right? And so to answer your question, right, we're passing by reference, right? At no point do we ever put the original thing into the function ever. We only put in a copy. So do what you will to it. When we console log out the original, it's still gonna be what it is. In this case, we're just gonna throw back a 4 and it's gonna go nowhere and it's gonna like die on the computer somewhere. Sorry, kind of morbid, but yeah, that's
sense,
what's
like,
like.
I don't understand why that's not changing the variable.
Well, yeah. So like so in that case, we don't even need new num anymore, right? Okay. So let's just say we have this like big like pot down here, right? We add some water to it, right? And this is a function, and we'll call it add. Okay. This is a function, right? When we're doing pass by reference, right? What happens is this goes into the pot. We do some stuff to it, and then it comes back out of the pot, right? And that's what this is, right? What pass by value does is saying, okay, I see your pot. I'm gonna create this little kid here. Sorry, not little kid, but I'm gonna create like a clone myself. This is what's gonna go in the pot. We're gonna do stuff to it, and this is what's gonna come out. And me, I don't get touched. Nothing ever happens to me. I'm still what I was originally. Right. So this is why that doesn't do anything to number, because number is still chilling up here, right? They was never put anywhere, right? The clone of number, the value number that we cloned and put in the pot, this changed, but because we're not capturing anywhere, it's almost like we don't have a reference. It doesn't matter to us anymore. Does that kind of help answer the question of why the original doesn't get changed? Okay, cool. Okay, and then this is yeah, and so this is a very similar example here. It's literally the same thing we just did, like use blue to keep it consistent. Right, objects pass by reference, right? Numbers pass by value. Strings pass by value. Same thing, right? I have my original thing. I'll call it a string here. What is it equal to? Hello. Line 19 now. I create a variable called newString. I call a function addWorldString. What do I? And so now this pot becomes addWorld. What is going into this pot? A what? A copy of hello? Yes? Right. Hello basically says, okay, I'm not going to do anything to myself, but I'm going to give you a copy of myself you can do whatever you want with. Great. I am also hello. Right? I'm going to go in the pot. I'm going to get world attached to myself. I'm going to come out of the pot. And, oh yeah, this is what newString is, right? So now newString is going to point to this. When we log it out, same idea. newString is now hello world. String, untouched, still just hello. No changes to it. Same exact concept with as we did with the 3 and the 4. Okay? Cool. So, okay, cool. All right. So, let's see how do you want to do this? Okay, cool. So now we're going to talk about like your question from earlier, right? Was what happens when we break, or how do we break it, right? What if I reassign something? So I'm going to keep all of this here. Delete this arrow here. Okay. So when I reassign something, right? If I'm dealing with non-objects, reassignment doesn't really matter, right? Because if it is something that like reassignment doesn't really necessarily matter, right? Because I'm just creating a copy of everything as I go along. So you can reassign all you want. Like I've only been dealing with your copy. I've never dealt with you directly. So you can repoint yourself all day, right? Doesn't matter to me, right? Reassignment becomes a bigger issue where it's like, okay, what if I'm pointing to the original, right? So let's go back to the first question we had here, right? Array of 1, 2, 3, right? ARR here. And what I posited to you guys was, great, let's just say that, like new ARR is not going to point to array, it's going to point to this. Okay? Okay. So was your question of what happens now when ARR repoints to something else?
Yeah, you assign ARR to a number.
Okay, right. So in our original setup, right, these are both pointing to the same array, right? Let's say that I created like a number out of nowhere, right? It's called 2, and now I basically point. This is a bad drawing here, but imagine these wires don't cross, but like this is just going like this, right? If I point to you now, this does not impact new AR at all, right? In fact, what I could also do is, what if I don't even point to this, right? What if I just point this to another array, right? Called 4, 5, 6. Okay. how we get here, just so everyone's clear on the exact steps which we get here, right? Step 1, we have this array called 1, 2, 3, right? Step 2, we say ARR equals to 1, 2, 3. Step 3, new ARR is equal to 1, 2, 3. Sorry, new ARR is equal to ARR, right? But the arrow does not get drawn like this, right? It doesn't get drawn from new ARR, it gets drawn like this. Cool? So now if ARR gets repointed to something else, that's cool, right? We were never depending on ARR to get us to where we need to be, right? We were always looking at the thing that ARR was pointing to, right? So now if ARR says, all right, let me be really cool and push like 10 onto my array, right? You can push 10 all you want. New ARR and 1, 2, 3 is not going to change. That's going to be constant, right? What is going to change is now what ARR is now pointing to, which is this new thing here.
There is no chain. Doesn't really.
Right, exactly. Well, it gets a little bit trickier here. So this is the last slide. So why don't we just, okay, so who wants to come here and try drawing this diagram out? Since everyone seems to have gotten it because there were no questions, really. Or we can pick out of a hat. Either way. I'll get rid of the pot because I feel like that's probably not going to be as useful for us. I'm going to do this too. So we start off with a computer with one slot and nothing else. Who wants to come up and try? And who wants to come up and try taking us through? We can do maybe like 2 people actually. You can do like different lines each. Who wants to come try it? You want to try the first few lines? Cool. There you go. All right. So do line 67, which is the first line.
We'll start with 1, 2, 3.
Cool.
And we say equal to R.
Yep. Cool. Okay, cool. And then we can create an empty variable called obj down the bottom somewhere. Cool. All right. And now we're passing in ARR. So what happens?
We're going to point to this value.
Right, yeah. We don't point to it directly, but yeah, like we're basically going to take this value and put it in do stuff function, right? So now, walk me through what happens in line 69. So let's erase this arrow for now because we haven't finished this just yet. But now walk me through what happens in line 69.
So then we have another new array.
Mm-hmm.
And we're going to set that equal to we're going to reference this value, right?
Yeah, pass by. Okay, so you're saying we're going to pass by reference. We're going to point to the same array.
Right.
Okay.
And then we're going to push the value of 4 to this reference value.
Cool. All right, that's it. You can stop there, and then we can have someone else finish up this rest of the function.
Me?
Yeah.
Okay, fine.
Cool. Okay, so he left you off on line. So he finished line 70, right? We pushed a 4 onto this. Now let's take it to line 71.
So then you have a new array, which is 4, 5, and 6.
Okay.
And this R is being assigned to this now.
Okay.
And then you're pushing 7. So 7 goes here.
Okay.
And then you're returning R, the value.
What am I returning?
The value
Sorry.
of this.
What I'm saying is that I'm returning basically a new object. So let's draw it out here.
Oh, let's do.
Right? Basically, this is just syntax for creating a new object, right?
Oh, okay, okay.
It's an object with things in it, but I'm just creating a whole new object, right? So,
Like,
squiggly, but yeah, same idea.
okay. And then I'm passing in this. Yeah. Right?
Well, you're passing in like, it looks like at least 4 things. So,
So the property and then the value.
right. Okay. So maybe this lay this out a little bit more clear really quickly. No, you're definitely right. So let's draw like this. So this is our object, right? We have this and this. Okay.
Yep.
We're gonna have key 1, which we're gonna call ARR, right? And you're gonna tell me what that's gonna equal to, and then we're gonna have something called new ARR, which is these are just string values, by the way. You can't tell from what they're, but basically these are just strings, right? So there's one thing here and there's one thing here. So tell me what each of these two things is equal to.
So what this is equal to?
Yeah.
4, 5, 6, 7, and 1, 2, 3, 4.
Can you draw the arrows for me?
Oh, from here?
Well, basically, basically these two things are going to fit here, right? So you can draw an arrow from this to one of these two slots, and an arrow from this to one of these two slots. Okay, cool. And then what we're gonna set that equal to?
Which one?
This whole thing, this whole block.
That whole thing will be equal to.
Or how are we gonna give reference to that?
It will be object.
Yep. Cool. Alright, cool. That was it.
Oh, good. Okay.
Okay. So this is where we are, right? A lot of lines, but you guys saw how we got there, right? Is anyone not clear on how these lines got drawn? Let's check to see how we did, right? So let's start at the bottom just because they're shorter, right? What's ARR? According to what we did, ARR is going to be equal to whatever. Did we draw this backwards? No, we just need to draw this backwards.
You said I was right.
I thought you were right too. Hold up. Oh man.
No, ARR is 1, 2, 3 because we don't change it inside the function. It's on 6
Except
and 7.
for variable.
We push a 4 to it. I'm thinking, where do we draw the arrow incorrectly?
Line 71, we changed the ARR.
Oh man. Okay, hold up. This is good. This is good.
Yeah,
this is
at
really good.
71, yeah.
We can work through this together.
At 71, we changed the whole value.
It's before R is assigned to 4, 5, 6. That's when it's equal to 1, 2, 3.
Okay, so line 81, object.arr, that's correct, right? And then line 80, new ARR is 1, 2, 3, 4, that's correct. Okay, so we know where we did inside the function we processed correctly. Let's think through as to why line 82 is not what we thought it would be. I think this might be something that I may have missed too. Var ARR is equal to 1, 2, 3. How's paragraph?
I think probably would have been right. It's just the fact that R confusingly is the name.
Yeah,
outside
I think
function and it's
I think it was named it weird.
So it should be another RRR?
Yeah, basically it's another ARR.
Oh, okay. So
Yeah.
it's
Yeah, so basically think about it just another variable ARR cut up there. So let's
I can write it.
sure, yeah, we can do like another ARR sum 1 or ARR sum 2. But let me just double check to make sure like that is in fact what's happening here. Okay, so let's reason through that, right? And Sean, feel free to join the party here. Okay, so we have a variable ARR. It's an array of 3 values, right? We're passing by a reference, which means we're changing the inside of it exactly. We're doing ARR.push, but then, oh shoot, my bad. Okay, right. Okay, so this is where I was like just mistaken, right? I think this is what we were going for, Sean, right? That like, okay, so.
So are there 2 ARRs? Or?
Right, like the AR, remember how I said like when you have 2 variables with the same name, like when you get inside the function scope, we're basically redefining it with like our own version of whatever
closure?
it is. Yeah, exactly, this is closure. So, so let me just go back here, right? So imagine, do you know how in the beginning we said 1, 2, 3 with ARR, right? When we went into our function, we basically created another variable called ARR inside, that's only used inside of our function, that also happen to point to this as well. So all these arrows that we've drawn, they're what happens to like the original arrow never changed. So actually, if you don't mind, I'm gonna redraw this again for you. So you guys both did great. I'm just redraw again so we can be perfectly clear on what's going on. We should change the naming of that. That is wildly confusing.
You could almost say like the one on 67 is called global ARR, and then the one inside is func ARR.
Yeah. I might just I might just call it AR still, like on the board I use different colors on it because I want it to be consistent with what's on the slide, just so like we don't like lose any like, so you know, I'm not like lying to you guys about like how all this works, like actually how this works. Okay. So, okay. So we have our box, our initial box, right? It has an array of 1, 2, 3 in it. Okay? Okay, cool. And then we have something called ARR that points to it. Okay? And then we're gonna, down here at some point, we're gonna create this thing called OBJ. Okay? We're not gonna point into it yet because we haven't finished creating it, our stuff yet, right? Inside of, so now we go inside the function, right? So this happened in line 78, which calls do stuff. So we go back into the function, now we're in line 69, okay? Essentially, what line 69 is doing is it's creating another variable, also called ARR, that's only useful inside that function that is pointing to this. Does that make sense? Like, this is why the name is the same, right? But you can, the colors, there are two different variables, so to speak. One exists inside the function, one exists outside of the function. One's global, one's local to the do stuff function, okay? This is the local one. Okay, and then inside of this do function, we also create this variable called new ARR. Okay, and we're gonna say this is now gonna equal to this as well. So now we have like a ton of stuff pointing to this 1, 2, 3 here. We're gonna say, okay, ARR, flat ARR, like local ARR, let's add a 4 to this, right? But this 4 is being referenced by everyone, right? So everyone gets a 4 added to their array here. And then in line 71, we're gonna say, all right, let's create this other thing called 4, 5, 6, okay? And let's set that equal to the local ARR, right? So now this changes back to this. Everyone good so far? So that was line 71. Line 72, local ARR. Let's push a 7 onto the end of our array here. And then let's return this whole new object here, that we call ARR, and then new ARR. New ARR, okay? What's going to go into local ARR? Whatever local ARR is pointing to, which is this. Okay. What is new ARR? New ARR is whatever this local new ARR was pointing to, which is this. Okay. So now when we console log out line 80, new ARR is going to point to 1, 2, 3, 4. ARR is going to point to 4, 5, 6, 7. And then the original ARR, we never changed. It's still 1, 2, 3. But because at some point we pushed the 4 onto it, and the reference to it never changed, we're now looking at 1, 2, 3, 4. So this is how like the proper diagram looks. We'll fix this slide in future iterations so that this isn't so confusing. But that's kind of what's happening here. Was that we were kind of like whenever we do this, whenever we pass an argument, basically all this does is in the function we create a variable called this equal to whatever value you passed it. Okay, so this is the final graph here. Does this? So this is equal to this whole object here. Does this make sense? Surprisingly, good. That's great. Yes.
So if we just return like ARR, it's gonna like change original.
If I just return ARR.
Yeah, instead of like returning an object, you just return ARR.
Okay, so what we're saying is rather than returning the object here, so I'm just going to delete all of this really quick so we can start afresh. What am I returning?
You are actually returning an object like here, but if you return ARR.
I return ARR. I return ARR. Okay, so if I return ARR, that's going to be whatever the local ARR is pointing to, right? Which is going to be this thing here.
Okay, so if you console log ARR, does it change the original ARR?
Does it change this? Well, this thing was changed up on line 70. Like that's where the 4 got added. Whatever I return here, once I've reassigned ARR here, so do you remember how like ARR, it used to be like this, where literally everyone was pointing to the same thing. This is in line 70 when we added the 4, right? And then I redirected this local ARR right to this. So at this point, like anything I do now is completely independent, and whatever I return is not going to change this. In fact, is there a way for me to get access?
Actually, how do you know that it's like when you're pushing the 4 that it's pushing it to the local one, not because it can only go has to go to that one.
It doesn't matter, right? I mean, like if we draw a diagram out, it's like, well, whatever this does can only impact whatever this goes to. So you're not like pushing it to this, which pushes to this. You're both pushing it to the same exact endpoint. Yes.
If the parameter was a different name though, like ARR1, would that be still pushing for to the global ARR where?
Yep. So in this function, let's say on line 67, right, we call it ARR global, right? So then this will become ARR global. Okay? And let's say when we pass the ARR global into line 78, right? And here, rather than call it ARR, we call it ARR local. What effectively happens then is now this becomes ARR local. But notice how where they point to does not change. If you want, we can sit down after this, and then I can kind of walk you step by step through kind of how to redraw this diagram in that way. But to everyone else, like it's kind of it should be like, I guess the most important thing we want to know is like, do these arrows make sense of what's pointing to what at which instance, right? Because the arrows tell us when we do something to that, what are we actually modifying at the end of the day, right? So as long as you have your arrows done correctly, everything else should be fairly straightforward, right? The question is now is, are you pointing to the right thing? Okay. This happens to be an instance in which everything's passed by what? Reference or value?
Reference.
Everything's by reference, right? Everything that we've created are things that we literally created, right? We create a new array, we create a new array, we create a new object, right? We literally just created. We didn't create anything by doing a pass by value, okay? So one last slide here. It's a summary slide. It's a lot of text, so take your time, read through it, but also let it digest. If you guys want to just take a look through it, let me know if you have any questions before we move on to the workshops. So I'll give you guys like 2 minutes to just like read through it. And I unfortunately can't zoom in. Oh, I can zoom in more. Oh God. Okay, that's the best we can get. Or not. Yeah. Okay. I hate computers. Okay, cool. As long as you can see it.
So is slice the only thing you can really do to?
There are a few functions you can do. Slice basically creates what we call like a shallow copy of it. There's object.assign, which if you pass in an object and then another object, it basically takes all the properties of the second object and copy out of the first one, I think. So there are a few things you can do to create it. But yeah, one of the things actually really interesting enough that you'll like work on, if you guys come to full stack, that is so you're gonna be working in React, right, which is a front end library, right, for how to basically make JavaScript things, make things run around the front end in your browser. React has something called Redux. Usually you get that like React Redux, right? That's like a very popular kind of pairing. React basically helps you like render like all the images, right? Redux helps you store all the data that you need to show on your website, right? So React could be like, here's where the title would go, and then Redux could contain the text for the title for that page. The reason why I'm telling you this, and there's a point to this, is that Redux has this very curious phenomenon where it's like, it has this global object that everyone can reference. However, you can't just change the object as you go along. You have to take the existing object, copy it, make the changes you want, and return a whole new object. And the reason why Redux does this is that if you make a mistake, or if you want to go back to an earlier version of this global library, you have all the historical copies of it, right? Because every time you tweak it, you're creating a new copy. You're never tweaking the original, right? So there is like very practical applications for why sometimes you want to copy something and then change it versus you want to change it directly.
Make it slow though.
React is actually incredibly fast. Yeah, it's super fast. That's why people didn't use it. If you want slow, I guess.
Well,
full-
it wasn't designed to be fast though, right? It was designed to be.
Yeah, so we can talk about like the plus and cons of different front-end libraries. But so these concepts, right? I'll just do a really quick 2-minute primer on them before we get started on the workshops.
No, I do have a question for
Yeah.
like the immersive program. I guess mostly the whole program is more geared towards like is it frameworks? I heard from somebody. Like you don't really learn programming challenges in the immersive program.
Yeah. So
Is it like that or?
yeah. So I mean, I don't want to spend too much time talking about like a specific program necessarily. But like what the full stack curriculum is, so you learn both front end and back end, and you do kind of learn different libraries. So basically, once you start becoming a programmer, you'll very rarely will someone give you like a blank sheet of paper and said, hey, can you like build from scratch something that does this, right? Like 99% of the code you're writing already exists in a code base, which exists in a framework, which already uses other libraries. So basically, the full stack curriculum is what they do is they help you how to write JavaScript, but also how to write it in certain libraries, that the most common libraries that you'll encounter, right? So full stack happens to teach full stack JavaScript, which means on the back end you'll learn Node, because that's I think the only way I know at least how to use JavaScript on the back end. On the front end, you'll learn React. We used to teach Angular too, so there's been some changes recently. So but basically you're learning JavaScript still, and the concepts that you learn like path by reference and function, like these apply anywhere, and they apply, I would probably say, in almost every language. Like
So React is a JavaScript library?
Yeah.
Okay.
Yeah. Yeah, it's like Facebook's like that project that just blew up, never loves it now. Okay, cool. So summary. Primitive values such as numbers and strings can only be passed by values. What does that mean? I have a value here. This is called 2. I have something called foo. I have something called bar. These are both variables, right? These two can never, ever point to the same primitive object, right? If I have this and I want to point bar to foo, I create a copy of 2. And so now what's going to happen is foo is going to point to this 2, and bar is going to point to this 2. Well, so that's the first principle. Second principle, with things like arrays and objects, we no longer have that restriction. We can definitely be able to do it. So now, if I have an array with just 2, I can point both of these to the same thing. And if bar does something to this array, then foo will also feel the impacts of that as well. 3, redefining a variable or slicing it breaks that chain, right? So let's say I have foo, or actually, you know what? Let's say I have foo and I have bar, and they're both pointing to the same array, right? If I say, hey foo, point yourself to bar.slice, right? Bar.slice means, okay, bar, where are you pointing at? You're pointing to a 2. Slice it means let's create a copy of you. So we create a copy down here, and then we say, hey bar, guess what? Or hey foo, guess what? This is now what you're equal to. Now we're basically redefining it, right? Same thing if I just created this array out of thin air and say, hey foo, this is your new value now, right? Bar's reference does not change, foo's does. That's all point number 3 is saying. And then the last one is kind of like this is kind of what I was talking about at the very beginning, is that like you don't necessarily like use this the way that you use like a map function, for example. It's something that's inherent in JavaScript, and it's really inherent in programming in every language. Like every language has their way of how to deal with this. That's right. So this is something that when you're writing code, be aware of it. If something breaks, make sure that this is not the culprit. But it is something that eventually you'll get a good feel for. As we saw earlier with that, when people came up and we made that mistake, right? This is why it's also very helpful to make your variable names robust, right? Is that you don't get confused by certain things, right? 5 different variables being named the same exact thing, and then you losing track of what's referencing what, right? So that's why robust variable names are also very helpful as well. Okay, cool. Any last minute questions before we pair you guys up? Oh wow, wait, no, 8 or 7? Gotta be 8, right? Okay. Haven't taken my clock yet. Cool. And then I know today's like obviously Patrick's Day and also a Friday. So what we're gonna do is like, if you guys obviously we're gonna pair you guys up. You guys spend some time working on it, and then maybe around like 9:15ish, I'll go through all this. Or if everyone's done really fast, we can go through this. We can go through the solutions together as well. One of the things about computer science that I really like is that like there's never like a perfect solution. Like at my job, like one of the things I keep doing is I keep rewriting the same code over and over and over again because other people look at it, it's like, hey David, you could be doing this a lot better this way, right? And you're like, oh wow, that is true. And so like computer program is as much about like writing something right the first time, or writing something the first time that does what we want it to do, versus polishing up like iteration after iteration to make sure it actually like is more optimized. So we can go through some of the workshop solutions together as well in 9, 10, 9:15, wherever you guys are comfortable. Sound good? All right, cool. Take a break, and then I will spike out pairs. Or we can just can we just like find a pair because it's. I mean, like the machine's randomly generated, so like most of you are missing. It might be like I might spend more time clicking a button than I do like picking pairs. So.
I mean, I guess everyone's pretty much doing it.
So we just me and
Yeah, work with whoever you're sitting next to. Yeah. Also, for you, I might just chat with her for like a little bit at the beginning.
Oh,
Then
yeah.
if she came late, I want to make sure she's like caught up on what's
No,
going
the
on.
transportation is like crazy.
Yeah, no, it's, the RW is especially like friendly. Cool.
I stopped recording.
Thought I did.
It looks like the old stop.